All right. So for this, which one doesn't belong? What did y'all get? Which one? This one right here? I'm sorry. That's right on. That one? So why does that one not belong? Okay, because the I is negative. Okay. It also is the only one that has addition, right? Okay, cool. All right, what else? There's more than one answer. First box doesn't belong. Why? Okay. It's an imaginary number instead of complex.
And if you simplify the third box, it will give you a real number.
The third box will give you a real number. Did you try simplifying the rest of them?
I think that that's complex.
Okay. All right. What about this one? Oh, I'm sorry. You actually see me right now. There we go. What about this box right here?
That's the one that was for you.
Okay, gotcha. So he's saying that this one will result in a real solution. Okay? And then what about this fourth box? Why wouldn't it belong with the other ones? Because what? Somebody also said that I squared is the only negative. Good. Why would that last one not belong? What's different about it from the other ones? It's got multiplication, okay? And then we also have a positive and a negative, right? So multiplying, and we got that positive and negative. Okay, good. So with these, which one doesn't belong? I really just want you to get like a number sense or just be aware of what's going on in the expression. Okay, so today we're going to talk about dividing complex numbers. So we've been talking about multiplying, adding, subtracting, and now we're going to actually do dividing. So one thing that we're going to use is called a conjugate. Okay, so a conjugate is, if this was your original expression, this is your conjugate of that expression. Okay, so I want you to take a moment. What's the difference between these two? This is your original, this is your OG, and then this is your conjugate. So what's the difference? Subtraction versus addition. So it's a change of sign for the imaginary term. Okay? So for instance, in this first example right here, you've got 5 plus 3i. And then for the conjugate, you got 5 minus 3i. So notice how the sign of the imaginary term is the only thing that changed. Same thing down here. You've got negative 2 minus 3i, and then negative 2 plus 3i. Okay, so sign is the only thing that changes. So I want you to take a moment. I want you to come up with your own example. Okay, I want you to come up with the original expression, so the OG, and then your conjugate. Okay, and it can be any number. Take like 30 seconds and think about it to yourself. Okay, so what did you get for your original? Somebody just share. 6 minus 5i. So what would the conjugate be for that 6 minus 5i? Exactly. Okay, so it's going to be 6 plus 5i. Okay, so conjugate means you're just going to change the sign of the imaginary term. Even if this first number is negative, you don't change that number on the conjugate, just the imaginary part. Okay, so now I want you to take a moment and I want you to match up the conjugates. So match the expression with its conjugate. Okay, so take a moment, write it down on your paper, match the original with the conjugate. For instance, if I had 5i, the conjugate of 5i is going to be negative 5i. Okay, so I've already done one for you. Go ahead and try that one. Okay, so the conjugate of negative 1 plus 2i would be what? Exactly. Okay, the conjugate of, wants me to pick a fancy color. The conjugate of negative 6 minus 5i. Exactly. the conjugate of 1 minus 2i,
1 plus 2.
okay? And the only things that are left are 6 minus 5i and 6 plus 5i, which are conjugates of each other, okay? So pretty simple. All you're doing is changing that sign. All right, so now let's actually get into like the meat and potatoes of today, okay? So we're going to actually divide. So I want you to go ahead and take a moment, and if this thing will let me drag it, go ahead and write this problem down on your paper, okay? So the conjugate is actually going to allow us to divide, okay? But I don't really necessarily like calling it dividing. It's kind of more like simplifying, because the goal of division is to get rid of that I in the denominator. We don't like having square roots in the denominator, and since I is the square root of -1, then we're going to try to get rid of it in the denominator. The way we're going to do this is we're going to take the conjugate, and y'all know like I like steps, so we're going to say multiply by the conjugate. If you're like, I'm not a step person, that's okay. You don't have to write it down, okay? So the first thing we're going to do is we're going to multiply by the conjugate. And the conjugate is this stuff in the bottom, okay, but we're going to change that sign. So 1 minus I. And we're going to multiply it in the top and the bottom, because if we multiply it in just the bottom, it's going to mess up our answer, okay? All right, so our first step is to multiply by the conjugate. So 5 times 1 is going to give us 5. 5 times -I is going to give us -5i. In the denominator, we have 1 times 1, which is going to give us 1. And 1 times I, -I, is going to give us -I. I times 1 is +I. And I times -I is -I squared. Okay? So all I've done, multiply by the conjugate. I'm so sorry that handwriting looks atrocious. So step 2. Step 2 is I'm going to simplify, or also known as combine like terms. Combine like terms. And y'all know how to do this because y'all awesome. So in this denominator, you can see that you've got -I and +I. Well, if I add -I plus I, that's going to cancel out, right? Okay, so this cancels out. So I'm going to rewrite what I have. 5 minus 5i over 1 minus I squared. Well, we still haven't gotten rid of that I in the denominator. We still need to get rid of it. So y'all learned on Tuesday, though, that on Tuesday, we learned that I squared is actually -1. Okay, so we're going to take -1, and we're going to plug it in for I squared. Okay, so I'm going to rewrite this. 5 minus 5i over 1 minus -1. Well, we still have a hot mess down there in the bottom. Okay, so our last and final step is going to be to simplify or combine like terms, whatever you want to use there. It's going to look different from problem to problem, but in this case, we're just going to simplify this denominator. So we're going to copy the top, and then in the bottom, we have 1 plus 1, which is going to give us 2. All right, so on number 2, we're going to multiply by the conjugate, so that's going to be -4i in the top and the bottom, right? You can't just multiply the top, or you can't just multiply the bottom. It changes your answer. Okay, so 3 times -4i is going to give me -12i. On the bottom, we have 4i times -4i, which is going to give me -16i squared. Well, our step 2 says to simplify or combine like terms. Well, I can't really combine a whole lot. Okay, so let's go ahead and jump to step 3. And we know that I squared equals -1. Okay, so I'm going to plug in -1 for I squared, which is going to give me -12i over -16 times -1. So now if I'm going to move on to step 4, I'm going to simplify what's in that denominator, right? So -16 times -1 is going to give us positive 16. But isn't 12 and 16 both divisible by something? What are they both divisible by? 4. So I'm going to divide by 4 in the top and in the bottom. Okay? So if I take negative 12 and I divide it by 4, I'm going to get negative 3i. If I take 16 and I divide it by 4, I'm going to get positive 4. One thing I want you to notice is that the original problem and what you finished with are kind of similar to each other. This is really only going to happen if the denominator only has an imaginary term instead of having the complex numbers. Okay, so just something to keep in mind. And if you ever have an I left in the denominator, you did something wrong. Okay, so you should never have an I in the denominator. It's okay to have it in the top, can't have it in the bottom. All right, go ahead and write number 3 down. And we're almost done, I promise. Well, with this part. Yeah. Actually, go ahead and try number 3 on your own. Okay, so you're trying number 3 on your own. And then we're going to check our work in just 1 second. Same concept that we've been doing. If you're watching this for the second time, you can pause the video and try it and check your work. Alrighty. So next one, we're going to multiply by the conjugate. Okay, hopefully you got that far. So if I multiply, I'm going to write this down here. I'm going to have 8 times 1, which is going to give me 8. 8 times 2i, which is going to give me 16i. 3i times 1, which is going to give me 3i. And 3i times 2i, which is going to give me 6i squared. Now, if you're sitting there and you're like, these lines stress me out, remember, Mr. McKinney showed you all that you could do the box method, right? Okay, so that's totally fine too. You don't have to do just the lines. You can do the box method as well. In the bottom, you've got 1 times 1, which is going to give you 1. 1 times 2i, which is going to give me 2i. Negative 2i times 1 is negative 2i. And negative 2i times 2i is negative 4i squared. All right, so we did the first step. Our second step is to simplify, right? And I can see that I've got 16i and 3i in the top and 2i minus 2i in the bottom. So in that top, I've got 8 and 16i plus 3i is going to be 19i plus 6i squared. In the bottom, we've got 1 and 2i minus 2i is going to cancel out, and I'm going to get negative 4i squared. Step 3, you've got I squared equals negative 1. So you're going to plug that in. So you're going to get 8 plus 19i plus 6 times negative 1 all over 1 minus 4 times negative 1. If I simplify, I'm going to have 8 minus 6, which is going to give me 2, plus 19i over 1 plus 4, which is going to give me 5. All right, so you're taking a second and you're writing down number 4, and then we're going to try it in just 1 second last time. So you're going to multiply by the conjugate. So the conjugate is going to be 2 minus 2i. So I've got 3 times 2 is going to give me 6. 3 times negative 2i is negative 6i. 2i times 2 is going to give me positive 4i. 2i times negative 2i is negative 4i squared. In the denominator, we've got 2 times 2 gives me 4. 2 times negative 2 is negative 4i. 2i times 2 is going to give me positive 4i. And 2i times negative 2i is going to give me negative 4i squared. Okay? Second step, we're going to simplify, so we're going to combine our like terms. In the top, I've got this negative 6i plus 4i. And then in the bottom, I've got negative 4i plus 4i. So if I simplify this in the top, I'm going to get 6 minus 2i minus 4i squared all over 4, and these will cancel out, minus 4i squared. My third step is to plug in that negative 1. So I'm going to plug in negative 1. And that last step is going to be to simplify. So 4 plus 4